Start na ma.
Yes, sige, go.
So good morning everyone. This is the group 4. We are going to report the activity 8 that we've conducted nung nag-face-to-face tayo. So for our objectives, I will be giving the virtual floor to Miss Olarte.
So, good morning, everyone. Our objectives in this activity are to state the formula for calculating the percentage yield of a reaction, to identify the limiting reagent in a chemical reaction using moles, to calculate the theoretical yield of a reaction, identifying the limiting reagent if necessary, to calculate percentage yield from the masses of molar quantities of the reactants or products, and to identify what factors may affect percentage yields. For the materials, I am giving the virtual floor to the next reporter.
So good morning everyone. So these are the list of materials and reagents used during the experiment. So first is the beaker, then sodium bicarbonate, then the hydrochloric acid, and then the oven. So beaker was used during the experiment as a container where we mix the sodium bicarbonate and the hydrochloric acid. So next slide please. Next slide po. So for the procedure, first is weigh a clean dry 250 ml beaker, then add approximately 2.5 grams sodium bicarbonate to the beaker, then accurately weigh the beaker and sodium bicarbonate. After that, slowly add the hydrochloric acid solution and about 10 to 15 ml and observe. No, then when the reaction has apparently stopped, add a few more ml of the hydrochloric acid solution to be sure all sodium bicarbonate has reacted. Then evaporate the solution to recover the product of the sodium chloride using the oven or burner. And take note that in burner, so you should heat slowly and carefully to avoid sputtering and heat in a hood. And also be careful not to breathe the fumes. So the next reporter will further discuss the results and the observations.
So for the results and observations during our activity, so for the data, the mass of empty beaker, which is 106.28 gram. For the mass of beaker plus sodium bicarbonate is 109.06 gram. For the mass of sodium bicarbonate is 2.79 gram. And for the mass of beaker and sodium chloride after evaporating is 108.28 gram. And lastly, for the mass of sodium chloride recovered is 1.93 gram.
So the problem given was from grams of sodium bicarbonate used, calculate the mole of sodium bicarbonate used and the mass of sodium chloride, which is the theoretical yield, formed using balanced equation. For getting the actual yield, we need to subtract the weight of the beaker, the empty beaker, to the mass of sodium chloride after evaporating. So the mass of our beaker with the sodium chloride after evaporating is 108.28 grams minus the mass of an empty beaker, which is 106.28 from our data above. So the answer is 2 grams. So the given is 2.79 grams of sodium bicarbonate. the formula we were going to use is weight of the given times molar mass of the given times mole ratio times molar mass of what is asked. For our solution, 2.79 grams of sodium bicarbonate is the given grams times the molar mass of sodium bicarbonate, which is 1 mole over 84 grams of sodium bicarbonate multiplied by the mole ratio, which is 1:1. So we write 1 mole of sodium chloride over 1 mole of sodium bicarbonate multiply to molar mass of what is asked, which is 58 grams of NaCl over 1 mole of NaCl. Our answer is 1.93 grams of NaCl. It is our theoretical yield. For our next reporter, I am going to give the virtual floor to Mr. Magallanes.
So using the mass of NaCl recovered, to calculate the mole of NaCl recovered, we are going to get the theoretical yield, which is yun yung nag-explain ni Gwyneth earlier na ang nakuha is 1.93. And then we are going to multiply it to 1 mole of NaCl over the molar mass of NaCl, which is the 58 grams of NaCl. And then we are going to cancel the grams of NaCl. And then pag na ano mo na siya sa calculator, ang maglabas na answer is 0.03 mole of NaCl. So for the next slide, how to calculate the percentage yield. So the given is yung actual yield namin is 2 grams because gi-subtract namin siya sa 108.28 grams. Tapos gi-subtract namin siya sa 106.28 grams. Kaya naging 2 grams because yung 108.28 grams is yan yung mass of beaker na may NaCl yung after nag-evaporate. So yung 106 is yan yung mass ng empty beaker nung sa analytical balance. So para ma-solve yung percentage yield, you need the theoretical yield also, which is 1.93 grams, yung i-explain ni Gwyneth kanina. And then yung formula is percentage yield is equals to actual yield over theoretical yield times 100. So maging 2 grams over 1.93 grams times 100, which is equals siya into 103.63%. So I will be giving the virtual floor to the next reporter.
So for the guide questions, for number 1, why can the percent yield theoretically not be greater than 100%? Use the law of conservation of mass. So the percent yield is the actual yield or experimental yield divided by the theoretical yield and multiplied to 100. The percent yield is 100% if the actual and theoretical yields are equal. Usually, percent yield is lower than 100% because the actual yield is often less than the theoretical value. This might be due to incomplete or conflicting responses as well as sample loss throughout the experiment. If the measured result of the reaction contains impurities that cause its mass to be larger than it actually is, the percent yields greater than 100% are possible.
Why is it necessary to add sufficient HCl to ensure the complete reaction of NaHCO3? So HCl is often used to neutralize alkaline bases. The reaction of saturated sodium bicarbonate with hydrochloric acid produces gas, which is the carbon dioxide. In a chemical reaction, an insufficient quantity of any of the reactants will limit the amount of product that forms. Next, please.
So for our conclusions, hence the air, vibration, and other factors can greatly influence the weight and results of experiment. In addition, percentage yield should not be greater than 100%. That would be all, ma'am. Thank you po.
Okay, can you go back sa first slide? Wait lang. Let me request. Paki-accept ng aking request. Okay. Sige. So, this one class is entitled Percentage Yield. This is still part of stoichiometry, but it's not just about theory since we conducted this experiment in the laboratory. Okay. So what we have here was the reaction between sodium bicarbonate, and please take note that we already weighed the sodium bicarbonate beforehand before the reaction with the hydrochloric acid. So in stoichiometry, even if you only know the amount of one reactant only, you can always compute and predict the amount of the product or the products if marami. So this time, again, our reactants, we have the sodium bicarbonate and also the hydrochloric acid, yielding one of the product is sodium chloride. The other one is the carbonic acid, in which after heating, nag-evaporate lang siya. So please take note that what is left in your beaker is the sodium chloride. Okay? Ayun yung next. Ayan. So ito yung inyong results. Mass of empty beaker, that's 106.28. If nilagyan na ng sodium bicarbonate, that's 109.06. Don't forget that sodium bicarbonate is our baking soda. And then mass of sodium bicarb is 2.79. Now, after the reaction and after the evaporation process, you have their mass of the beaker and sodium chloride. That's 108.28. And this is the mass of NaCl recovered. Tama ba? 1.93 yung recovered niyo. When you say recovered, that's the actual yield. 108.28 minus the mass of the empty beaker, that's 106.28. That should be 2. Okay, please take note. The mass of the sodium chloride recovered there, that should be 2 grams. That is your actual yield. After heating, after the evaporation process, that's the mass of the NaCl recovered. Okay? Sige, ay, nasobrahan. So, ito, for grams of sodium bicarb used, calculate the moles of, yung moles lang yung tinatanong dito, used and mass of the NaCl. So, I think moles and mass yung hinahanap. And then, formed using the balanced equation. So, again, the actual yield is 2 grams. Kulang lang yung yung solving ninyo class kasi if you read the problem properly, calculate both the moles and the mass. The mass should be in grams. So ito, tama ito. This is in grams. 2.79 grams of sodium bicarb. We are going to use the whole pattern. So times the molar mass of the sodium bicarb, that's 84 grams per mole. And our mole ratio here, since our chemical equation is sodium bicarb plus HCl yielding NaCl plus carbonic acid. Wala namang coefficient dyan, so 1:1. And for the sodium chloride, that's 58 grams per mole. I've computed this already a while ago. This is correct. This is the mass of the NaCl. But kulang lang siya kasi again, pinakompute din kayo ng moles. So, dapat meron din kayong computation na ganito. 1 mole of NaHCO3 divided by 84 grams. Ay, sorry. Nilagyan. Okay, 84 grams of sodium bicarb times, dapat meron kayong computation na hanggang dyan lang. Merong 1 mole ng NaCl sa 1 mole ng sodium bicarb. Okay, cancel the grams, the moles of the sodium bicarb, and then again, you will be left here with the moles of the NaCl. Kulang lang. Yun yung nasali yung moles ni NaCl. So this is 2.79 times 1 divided by 84. 2 decimal places, meron dapat kayong sagot dyan na 0.03 moles of NaCl. Okay? So yun lang yung kulang sa report. I just don't know in your submission if nasali ba ito. You have questions regarding this one? Or clarifications? Ito yung theoretical yield ha. Kasi supposedly, this should be produced if you have 2.79 grams of the sodium bicarb. However, in your experiment, you produced 2 grams. So that's more than the expected yield. So the next step is to compute for the percentage yield. Ay, nandito pala, sorry. Hindi ko pala ito nakita kanina. I missed this a while ago. Sige, it's okay. So, parehas tayo ng answer, 0.03. Okay. Now, for the percentage yield, ba't ayaw gumana ng aking mouse? Ay. Okay, for the percentage yield, take note of our formula class, ha? Percentage yield is equal to the actual yield divided by the theoretical, ganyan ko lang isulat ha, times 100. So do not forget the 100. So you don't have class A unit here except for the percent. Okay? So 2 grams, mas malaki yung inyong yield, actual yield kesa sa theoretical yield. 2 divided by 1.93 times 100. 103.63. Okay, 100. This is your theoretical yield, 103.63. I think we have mentioned the possible reasons why you have more than 100%. Pero actually, class, yung kanyang concept talaga and our rule here is that the percentage yield should not be greater than 100%. So you will use the law of conservation of mass sa pag-explain why we cannot have a percentage yield of greater than 100%. Okay? So remember, according to the law of conservation of mass in a chemical reaction, the matter cannot be created nor destroyed. So pwede magkaroon ng rearrangement, 'di ba, may double displacement na nangyari, exchange partners, but when it comes to the amount of the matter of the substance, supposedly parehas lang yun siya. Hindi dapat siya mabawasan, hindi dapat siya madagdagan. That's the law of conservation of mass. So since that is according to the law of conservation of mass, tapos nagkaroon kayo ng more than 100%, there might be possible contaminations. Depende na kung saan yung contamination nangyari. If pwede yung contamination is nasa sodium bicarb or nasa hydrochloric acid, adding to the weight of the recovered NaCl, or dun mismo sa mga beakers na ginamit ninyo sa mga laboratory equipment, or due to the weighing. So, hindi natin alam if the analytical balance is still properly calibrated, though we have calibrated that before the weighing. Pero, syempre, there are errors with the machine. So, pwede yun siya maging reason why you got more than 100%. Okay? So kung nakakuha naman kayo ng below 100% na percentage yield, so pwede din yun siya because of weighing error, machine error, or maybe there is procedural error, like there is spillage of your substances during the reaction. Okay? Or by the way, pwede din palang more than 100% if yung inyong NaCl recovered is hindi totally nag-evaporate yung liquid portion. So remember that the carbonic acid is being evaporated, and kapag hindi yun siya totally na dry, syempre mag-a-add yun siya sa weight of the sodium chloride in your beaker. So again, pwede din yun siyang reason why you got more than 100%. Why is it necessary to add, why is it necessary to add sufficient hydrochloric acid to ensure the complete reaction of sodium bicarb? Okay. Okay, sige, very good. An insufficient quantity of any of the reactants will limit the amount of the product na mafo-form. So tama yan siya. So you have there initially 2.79 sodium bicarbonate, I mean, sa grupo ninyo, hindi natin alam yung sa kabilang grupo kung ilan yung ginamit nila, but nevertheless, we really have to add sufficient amount of hydrochloric acid for us to ensure that the total 2.79 grams na sodium bicarb is used in the reaction. Okay? Nagkaroon ng reaction lahat with the molecules of the hydrochloric acid so that we can also get the maximum amount of products. Kasi kapag kulang ng hydrochloric acid, merong mga sodium bicarb na hindi siya maiiwan siya doon. So, walang reaction na nangyari and you cannot get the desired amount or the target amount na sodium chloride in the end, which is our product. Okay? So, I think that's it. Any question regarding this experiment? I hope you learned something while doing the experiment. You enjoyed the experiment, though hindi naman talaga mahirap yung kanyang procedure, and then actually, mabilis lang siyang matapos. Pero I hope you appreciated the stoichiometry based on that experiment. So we will have our next set of face-to-face laboratory class sa finals. So that this time, we are going to do titration.